If you're trying to watch part 2 of the video without watching part 1, this is going to get real confusing. So I would suggest going back and watching part 1 first, taking the notes on that, and then doing this with me. Otherwise, it's not going to make a whole lot of sense. So to split this into, simplify each number using the imaginary number I. Okay, we know that we can split this up into the perfect square. Remember that the -1 comes with the perfect square and leaves the leftover trapped inside. You can't bring that non-perfect square out. And of course we know that this is 2i radical 5, right? The square root of -4 is 2i. We break it down into the square root of -4 and the square root of -1. Of course this is I, just like you saw in the video, the first video. Okay, so 2i radical 5 is the complex, the simplified complex version. If we come over here, we have 2. We can break this up into a perfect square with its leftover. The perfect square that I know that goes into 75 is 25, and it goes in 3 times. The negative comes with the 25, so that's 2 times 5i radical 3, or 10i radical 3. I don't care if you make your i's with this little italicized look or without. It doesn't really matter to me. As long as I can tell. We never put the I on the other side, just because somebody might think that the I is inside the radical when it is not inside the radical. Write each number in a plus bi form. That means the real number first, and then the imaginary part second. That's how you write complex numbers with the 2 parts. So, square root of -45, that can be split apart into a perfect square. 9 goes in 5 times, and the negative goes with the perfect square. So this would be 3i radical 5. And of course, we've got the plus 10. That is not a plus bi form. The real number has to come first. So 10 plus 3i radical 5 is your final answer. Over here, 49 is a perfect square, and when we take the square root of -49, this minus comes down, but this becomes 7i, and then a -6. Of course, if you want to write that in a plus bi form, the real number portion comes first, and the imaginary portion comes second. Question 9, okay, graphing. We'll graph 9 here, and I'm really hoping something, but I'm going to check on the first video before I open my mouth. Okay, I was right. I just went back and looked at the video. The first video talks about graphing, so if you're wondering how this is being graphed, remember the real axis is kind of like the number line that you used to graph all kinds of things on a number line. 0, 1, 2, 3, 4. Okay. Those kind of things used to be graphed on a number line. You're used to graphing things, well, like if I ever asked you to graph the number 5, you'd come over and put a dot there, right? That would be something you'd do like in elementary school or middle school or something like that. Well, the number line, we did stuff with the number line at the beginning of the year, but it was like, x is greater than or equal to 5. So we would have closed, circle, arrow, right. Well, this is just an individual point. Well, 5 plus 2i, the complex number plane was actually there even when we had a number line. We didn't talk about it back in elementary school. We didn't want to scare the children, really. So 5 plus 2i, 5 to the right and 2 up, there it is. There's the coordinate, 5 plus 2i. It's an actual place in the universe. And yes, it's kind of, or in the complex number plane. You know what? If I owned my own airplane, that'd be a good name for it. Wouldn't it be complex number? Anyway, coordinates like this can be found just like if you had the coordinate 5, 2. Now, it also says in this question, find the absolute value. So absolute value, the absolute value of 5 plus 2i. Now, what do we know about absolute value? According to the video, we talked about it being a distance. a distance away from the origin. Okay? And that would really look like a right triangle. So 5 plus 2i is just a dot. But because they're asking me for the absolute value, I'm trying to find the distance. Now, how long is this side of the triangle? Well, I hope you say that it's 5. How long is this side of the triangle? Well, I hope you say it's 2. And so the absolute value is the good old Pythagorean theorem, the square root of 5 squared plus 2 squared, which is obviously the square root of 25 plus 4, or square root of 29. Okay, and that is the absolute value, the distance away from the origin, 0 plus 0i. Okay, and I'll leave those other two for you to practice with. Okay, adding or subtracting, just to practice with these. Adding is easier, in my opinion. All right, less of you make mistakes with it. So if I'm adding these two numbers together, I'm going to add the reals and the imaginaries. Now notice that I just lined them up, one under the other, and I'm going to add them together. Negative 3 plus 4, negative 5i minus 2i. That's it, folks. That was as hard as it gets. And I put them in real numbers together, imaginary numbers together. Now, a lot of you kids are going to think FOIL when you see this. And the reason you think that is because you see parentheses. And as soon as you see parentheses, you go crazy and think, multiply them together, FOIL. And I promise you some people are going to do that. You're going to lose all the credit because this is a simple adding problem. Make sure you're not multiplying these. Now, when you get to subtraction, remember that you're distributing a negative to both of those. This is what makes it interesting here. I'm going to change this problem to addition by distributing that negative. So I have a negative 2 and a positive I. And now I've changed it from a subtraction problem to an addition problem. So we can get 10 and 6i. And that's as hard as that subtraction problem got. But just remember on the subtraction, you have to distribute the negative. Okay, let's see what's on the next page. Okay, question 15. 6i times 9i. Well, you can treat the I just like a variable, and so 6 times 9 would be 54, and that would be I squared. Now, in the other video, I reminded you that I squared equals negative 1. So this is really 54 times negative 1, and I think everybody knows that that's negative 54. Now here's a problem where you are going to have to do FOIL. Now, whether you like a box or don't like a box, it's completely up to you. I don't really care. I'm flexible. So I'm using a box underneath this one, and I'm going to take this one and drop it down the side. And then I'm going to match things up, negative 6 times 1. Negative 6 times 3i. 1 times negative 5i. Negative 5i times 3i is negative 15i squared. Obviously didn't leave myself enough room there. What is negative 15i squared? Isn't that negative 15 times negative 1? So isn't this really positive 15? Now then you got to add like terms. I see negative 5i and negative 18i, that's negative 23i. And then I see 6 and 15, they are like terms, or negative 6 and 15. And if I have negative 6 and 15, they add up to 9. So 9 minus 23i is our product. You're just foiling them together. And whether you like to draw the arrows and connect things up, or whether you like to use a box, it doesn't really matter to me. Now, if we are solving by square rooting, like is in question 20, notice that there is no linear term. No linear term. This is when we know that we can use the square rooting method for solving. So, I am going to add the 100 to the other side, divide by the coefficient -1, and then take a square root. And just remember, when you do this, in a solving situation, there are two answers, positive and negative, and the square root of -100 would be 10i. And those are the two solutions. And we did not have to factor anything because there was no linear term. Now, because of the form the question 22 is in, I do not have to factor that one as well. Okay, it's kind of in a factored form almost. So what are we going to do here? Well, we're trying to get x plus 4 by itself. So the first thing I'm going to do is add the 6 to the other side. Please resist the temptation to FOIL. That is the last thing you need to do here, is FOIL. I do need to get rid of that -2 by dividing. What would that be? -123. Then I need to take the square root. So this would give me x plus 4 equals positive and negative. Remember, there's always going to be a plus and a minus. Now, 123. Do any perfect squares go into 123? Man, if only I had a really cool quick calculator to get a hold of. But I do not, so I'm going to have to improvise, and it may take me a second here to do this, but let's see here. 123, well, 3 goes into it 41 times. Well, that tells me the answer to my question, right? If 3 goes in 41 times, they're both prime numbers, so I can't do anything with that. The only thing that's going to come out of this is that negative. So we have I, and then the 123 is not something that breaks apart, doesn't have a perfect square trapped inside of it. As soon as I divided this and found out it was 3 and 41, that are multiplied together, those are both prime. There's nothing I can do. There's no perfect square like 9 or 25 or 7 or anything. So the last thing I need to do is subtract 4 on both sides. So x equals, that would cancel out. Now these things, one's a real number and one's an imaginary number. So we're going to have -4 plus and minus I radical 123. There's your final two answers. Those are both two different answers, and I can't do anything with them. That's as good as it gets. So, work on some of these problems. We'll definitely work on them in class tomorrow as well.